Hello friends, today I am going to discuss two conceptual questions which are taken from NET exam, right? So let's start with our first question. Here our first question is which of the following real valued function on 0 1 open interval is uniformly continuous? And here the option given below are, this is the first option, fx equals to 1 by x. Here the second option is this, fx equals to sine x by x. The third option, fx equals to sine 1 by x, and the fourth option, fx equals to cos x by x. So which of the following real valued function on this interval 0 1, right, on this interval 0 1 is uniformly continuous? So to solve it, you have to know a simple theorem. And actually, the theorem related to this uniform continuity says that suppose f of x be a function, right? Suppose f of x, this is a given function. Now, so here f of x be a given function, and suppose you are given an interval. Here I am taking the interval as AB, right? So you are given an interval AB, and this function f of x is defined on this interval AB. Now this function f of x is called uniformly continuous throughout this interval AB if it is continuous within this interval AB and the limit at both ends exist finitely, right? So that means limit x tends to a f of x exists and limit x tends to b f of x exists finitely. So if f of x satisfies this condition, that is limit x tends to a f of x exist and limit x tends to b f of x exist, and f of x is continuous within the interval open interval AB, then you can say that the function f of x is uniformly continuous throughout this interval. Then you can say that the function f of x is uniformly continuous throughout this interval AB, right? So this is our theorem, and with the basis of this theorem, here I will find out the correct answer, right? So this is our first function f of x equals to 1 by x, and as you can see that the function 1 by x, this function is continuous within every point within this interval, right? Every point within this interval, and also x equals to 1. But if we put x equals to 0, then the function will be something undefined, right? Something by 0 will be undefined. But here you need to take the limit at these two endpoints. So here find out the limit of this function f of x as x tends to 0. So if x tends to 0, then f of x, this tends to infinity. So limit does not exist at left endpoint. Therefore, it will not be uniformly continuous according to our theorem, right? But here the limit extends to 1 f of x, this is exist, right? If you take f of x equals to 1 by x, then limit extends to 1 f of x equals to 1, this is exist. But left hand limit extends to 0 f of x is not exists, right? Does not exist. So that's why this option is not a correct option. And similarly, at endpoint x tends to 0 sin x by x exists finitely, and x tends to 1 sin x by x, this is also exist finitely, that is sin 1 by 1, that means sin 1. So here, since f of x is continuous within the interval 0 1 and limit exists at two endpoints, therefore this option will be our correct option, right? So this is our correct option, and you may verify or check this, that sin 1 by x, this also again the limit of this function f of x equals to sin 1 by x does not exist when x tends to 0, and Similarly here f of x equals to cos x by x. So here just taking the limit x tends to 0. So for x tends to 0, something by 0, so limit does not exist, right? Cos 0 means 1 by 0, so limit does not exist. So our correct answer will be this option, option B. So to find out this type, to solve this type of question, you have to remember the theorem which I have discussed. Now our next question is here. This is our next question. Next question is, which of the following is true? Which of the following statement is or are true, right? The first option, there exists a continuous map f maps R to R such that f of R equals to Q. Is it possible? Here one thing, you just here one thing, note that f of R equals to Q. Here this R is connected set and this Q is not connected set, right? So R is connected set, R actually represent a line, and a line, you can stretch this line infinitely from both ends, right? So R is connected and Q is not connected. Why Q is not connected? Q is a set of rational number, and between any two rational number there exists an irrational number. So that's why R is Q is not connected, Q is disconnected. And here there exists a mapping f maps R to R such that f of R equals to Q. So this type of mapping does not exist. That is, as we know that the image of connected set will be connected, but here the image of connected set will be connected set under continuous mapping, right? So if we consider here the mapping is continuous and here the set R is always connected set, so f of R will be connected, but we know that Q is disconnected set, right? So here FR is connected but Q is disconnected. It is not possible since we are given f of R equals to Q, so which is a contradiction. Therefore from here we can conclude that there does not exist any continuous map from R to R such that f of R equals to Q, right? So our first option, this is wrong, this is incorrect option. And similarly you can prove that f of R equals to Z, this is not possible. There does not exist this type of mapping, as Z is disconnected but R is connected and the continuous image of connected set will be connected, right? So this is not possible. Now the third option. So here the third option, there exists a continuous map f maps R to R square such that f of R equals to this. So here as you can see that this set R, this is connected set, right? And here the image set f of R, this is defined as xy belongs to R square such that x square plus y square equals to 1. So actually f of R represent all those points which lies on the boundary of the circle, right? So that is this set actually represent just a circle point. So this xy actually points on this perimeter of the circle, right? Arbitrary point. So here this circle, this is also connected set and R is also connected set. R is connected and the image set, this is connected. So there may exist a continuous map. There may means there always exists, right? There always exists a continuous map from a connected set to connected set, right? So this is a connected set R, and this f of R, this is also connected set. So you can find out a continuous mapping from the connected set this to this, and you may write this mapping as this way. So here you can use this concept, f of theta equals to e to the power theta, right? So this is a continuous map e to the power I theta. Of theta equals to e to the power I theta. So you can use this map for an example of continuous map. So here our option C, this option is true. Since R is connected and f of R, the image set, is connected according to the definition of the range set, right? And here there exists a continuous map, A maps closed interval 0 1 union 2 3 implies closed interval 0 1 union 2 3 to 0 1, right? So 0 1 means this is actually represent a finite set 0 1. So this option D will be true. Why this option will be true? Just look at this Arson lemma. Look at this lemma, Arson lemma. This lemma is called Arson lemma. Most important. This is the most important result. If X be a normal space and A be a two disjoint closed subset of X, and let AB be a closed interval in the real line, then there exists a continuous map F maps X to AB such that f of x equals to A for every x belongs to A, and f of x belongs to B for every x belongs to B, right? So according to this lemma here, as you can see that A, B are two disjoint closed set of X. So you can consider this total set, that is 0 1 closed interval union 2 3, this is equals to capital X. You can consider this whole set as capital X, right? So this is our capital X, and this 0 1, this is A. This 0 1, this is, you can consider this as capital A, and this 2 3, this is capital B, right? So now just compare this mapping with this mapping. Compare this mapping with this mapping. So as you can see that f of x equals to, here it is possible f of x equals to A for every x belongs to A, and similarly f of x equals to B for every x belongs to B. So it is possible to find out such type of maps according to Arson lemma. So that's it. Thank you.